Have you ever just looked up at the sky and wondered what is really going on up there? Behind the scenes of our daily weather. It can feel so chaotic, so unpredictable. But believe it or not, it's all governed by just a few really elegant, invisible forces. So let's dive in and pull back the curtain on the engine that drives our world.
We all do it, right? First thing in the morning, you check the forecast. You see all these numbers and symbols for sun or clouds or rain. It's just part of our daily routine. We glance at it, we see a high of 32 in Cairo, maybe a low of 16 in Alexandria. We see the information, but do we really understand the story it's telling us?
Because behind every single one of those numbers and every one of those symbols, there are these incredibly powerful forces at work. It's like this giant global dance of energy and physics happening all around us. So, what are these forces? Well, that's exactly what we're here to break down.
Okay, first things first. Before we get any deeper, let's clear up something that trips a lot of people up. We hear the words weather and climate thrown around all the time, sometimes like they mean the same thing, but they're fundamentally different, and the distinction is super important.
Here's the easiest way to think about it, and I love this analogy. Weather is your mood. It's what's happening right now. Is it sunny? Is it rainy? Is it windy? Your mood can change from one hour to the next, right? Well, that's weather. Climate, on the other hand, is your personality. It's the long-term average, the bigger picture. You might be in a grumpy mood today, but your personality is generally cheerful. See the difference? Mood versus personality. Weather versus climate.
So if we're going to really understand this whole weather engine, we have to start with its fuel source. The number one main ingredient that kicks this entire process off, temperature.
And listen, temperature isn't just about whether you need to grab a jacket or not. It literally dictates where plants can grow, where animals can live. Everything from the polar bear in the freezing Arctic to the camel in the blazing desert. It is, without a doubt, the single most important factor shaping life on our planet. So the big question is, what controls it?
Well, it turns out there are three pretty simple rules that have a massive impact on temperature all across the globe. Let's break them down one by one. It all comes down to latitude, altitude, and how close you are to water.
Okay, rule number one is latitude. Imagine the sun's energy is a flashlight beam. Right at the equator, the sun is pretty much directly overhead, so that flashlight beam is focused, it's concentrated, it's intense, and that makes it hot. But as you move up towards the poles, the Earth's surface curves away, so that same beam of light hits the ground at an angle, and the energy gets spread out over a much larger area. Less focus means less heat. It's really as simple as that. All right, next up, rule number two, altitude. We all know it's colder at the top of a mountain, but why? Well, as you go higher up, there's less atmosphere pushing down on you. This allows the air to expand, and just like any gas, when it expands, it cools down. The little air particles have more room to spread out, they lose energy, and boom, the temperature drops. And finally, rule number three, water. Water is kind of a superstar when it comes to holding on to heat. So during the day, land heats up way faster than the ocean. This makes the cool air from over the water rush in, creating that amazing sea breeze. But at night, the opposite happens. The land cools down super fast, but the ocean holds onto its warmth. So now, the warmer air over the sea rises, and cooler air from the land flows out to replace it, a land breeze. This beautiful daily cycle is exactly why coastal areas have much more moderate, stable temperatures. Okay, so we've got temperature down, but there's another major player in this story, an invisible force that is literally pushing down on you right now, and you don't even feel it. We're talking about atmospheric pressure.
I know what you're thinking. Air? Wait. No way. It feels like nothing, right? It seems totally weightless. But what if I told you that the huge column of air stretching from the top of your head all the way to the edge of space has actual, measurable weight?
And hey, you don't have to take my word for it. We can prove it with a really simple experiment. If you take two inflated balloons and balance them perfectly on a stick, and then you pop one. Look at that. The other balloon immediately drops down. Why? Because the air that was inside it had mass. It had weight. That's the proof right there in front of you.
Want to see the power of that weight? Check this out. You light a piece of paper, you drop it into a bottle, and you place a peeled, hard-boiled egg on top. Now watch. As the paper burns, it heats the air inside, making it expand. But the second that flame goes out, the air inside cools down fast. It contracts, creating a low-pressure zone. And that stronger atmospheric pressure on the outside literally shoves the egg right into the bottle. It's not magic, it's pure physics in action.
So let's just lock in that definition. Atmospheric pressure is simply the weight of that column of air we talked about pressing down on a certain area. That's it. That's the invisible force that just pushed an egg into a bottle.
Okay, so we have our two main ingredients. We've got temperature and we've got pressure. Now it's time for the big reveal. Let's put them together and see how they create the engine that drives every bit of our weather.
This is it. This is the single most important relationship you need to remember. When air gets hot, it expands, it gets less dense, and it starts to rise. That creates an area of lower pressure. On the flip side, when air is cold, it's dense and it sinks, creating an area of higher pressure. Hot equals low pressure, cold equals high pressure. Say it with me. Hot is low, cold is high.
And here is the grand finale. The universe absolutely loves balance. It's always trying to even things out. So air will always flow from an area of high pressure to an area of low pressure. And that movement, that flow of air from high to low, is what we call wind. Every single breeze you feel, every gust, every storm on this planet is driven by that one simple principle.
So there you have it. Temperature differences create pressure differences, and those pressure differences create wind. It's this beautiful, delicate engine that keeps our entire world in balance. But understanding these rules, it leads to a really crucial final thought. If we know exactly how the engine works, it also means we understand how it can be disrupted. And that leaves us with a pretty big question to think about. What happens when our actions start changing the very rules that govern our planet's weather?